Okay guys, in today's class, we are going to look at some post-UTME past questions and answer under chemistry. Now the first question here says, alum are classified as. Now before we begin, we have different types of salts. We have the normal salt, the acidic salt, the basic salt, and double salt and complex salt. These are the types of salt that we have. Now, among these type of salts that we have, alum is one of them. And alum is what? A double salt. So whenever you see a question that asks about alum, what type of salt is alum? Alum is a double salt. It's a salt that comprises or that constitutes of two or more simple salts joined together. So that is basically it for that. Of course, we know that when acid and base react, salt and water are formed. The 5 types of salt are normal salt, acidic salt, basic salt, double salt, and complex salt. And alum is a double salt. So the correct answer to that question is option D, double salt. The next question says that the nucleus of the isotope tritium contains. Now, what is isotopy? Isotopy is a phenomenon by which an atom has the same, or an element has atoms which have the same atomic number but different number of protons, which therefore leads to different atomic mass or isotopic masses. So that is basically it for what? Isotopes. So all isotopes of an element has the same number of protons, which is the atomic number, but different number of neutrons, which ultimately lead to different what? Atomic number. Tritium is an isotope of hydrogen. Hydrogen has 3 isotopes. The 3 isotopes are, we have protium, P, deuterium, and tritium. Of course, all of them has one word? Atomic number of 1. So each of them has atomic number of 1. But these 3, they have different number of neutrons and ultimately different atomic mass or isotopic mass. Protium has atomic mass of 1. Deuterium has atomic mass of 2. Tritium has atomic mass of 3. Now, from our illustration or from our previous study, we established that the number of proton plus that of neutron is equal to the atomic mass. The number of proton plus that of neutron is equal to the atomic mass. Now, the superscript here for each of them is the atomic mass or the isotopic mass. The superscript here is the isotopic mass, while the subscript is the number of proton, which is the atomic number. So the number of proton for each of them is 1. Now, if we want to look for the number of neutron, what do? We make n the subject of the formula. Making n the subject of the formula, P has to come to this side. So we have n is equal to the atomic mass minus the number of proton. So the atomic mass minus the number of proton will give us the number of neutron for each of them. Now, let's take for the first one, protium. Now, the number of neutron is equal to, what's the atomic mass? 1 minus the number of proton, 1. 1 minus 1 is 0. Now, taking deuterium, number of neutrons is equals to, atomic mass is 2 minus number of proton is 1, which is equals to 1. Then taking tritium, the atomic mass is 3 minus atomic number 1. 3 minus 1 is what? Is 2. So you see that each of them has number of proton differ. The number of proton for this one is 0 and this one is 1, this one is 2. Now they now ask you, tritium, what is the constituent of tritium? Now we have A. That's the option A. Now the correct option is option C. From the illustration, we can see that tritium has how many proton? It has 1 proton. Rather, tritium has 1 proton because all of them has the same number of proton. Then how many neutrons does it have? 2. We said N for tritium is equals to 2. So the composition is 2 neutrons and 1 proton. So that is basically it for this question. Let's take question 3. Question number 3. Question number 3 says that if 100 centimeter cube of oxygen, so we have our volume is equal to 100 cm cube, diffuses through a porous plug in 50 seconds. The time is what? Time for diffusion of oxygen is 50 seconds. Calculate the time taken for the same volume of hydrogen to pass through the same plug. They gave you the atomic mass to be 16 for oxygen and that of hydrogen to be equal to 1. Now, from the Gram's law of diffusion, the Gram's law of diffusion states that the rate of diffusion is inversely proportional to the density. The rate of diffusion is inversely proportional to the square root, rather, of the density. Is inversely proportional to the square root of the density. Now, from here, if we introduce the constant K, this becomes rho is equals to K times 1 over root density. So our rho is equals to K root what? Density. K times 1 is K. Then we have over root density. Now, from here, we can establish that our K cross multiply, K times 1 is K is equals to rho times root of the density. It's equals to rho times the root of the density. Now, have we gotten this? What's the next step for us to take, or what's the next step to take for this particular question? It's very easy. Now, the next step is we can say our K is equals to rho 1 times root d1, where rho 1 is the rate of diffusion of what? Oxygen, and root d1 is the density of oxygen. So from here, we can also establish that for any other gases, rho 1 or rho 2 root d2 will be equal to rho 1 root d1 will be equal to rho 3 root d3. Now that is basically it for this constant. That is to say, for every other one, it is constant like that. They are what? Equal. Are you getting it? So you equate them for each of them. For any gas given to you, you can go to the third, to the fourth, to the fifth. Now let's work with just this one here. From here, we can make this derivative of the formula in such a way that we have our rho, we have rho 2 all over rho 1 is equals to root what? d1 over root d2. Now, we know that our rate or our density is directly proportional to the molar mass. Density is directly proportional to the molar mass of a gas. The density is directly proportional to the molar mass, because, or to the mass, because density is what? Is mass over volume. Density is directly proportional to mass and inversely proportional to the volume. So our density is directly proportional to the molar mass. So in this case, we can say that rho 2 over rho 1 is equal to root m1 over root m2. Basically, when you get here, note that rho 1 or rho 2 is equals to 1 over t2. That is to say that the rate is the inverse of the time of diffusion. Now, basically, you don't need to prove all these ones if you already have the something in your head. So from here, we substitute this into the equation. In place of rho 2, put 1 over t2, and in place of rho 1, you put 1 over t1. So this becomes 1 over t2 over 1 over t1 is equal to root m1 over m2. Root m1 over m2. Now, You agree with me now? 1 over T2 divided by 1 over T1 is still the same thing as 1 over T2 times 1 over or times T1 over 1. Why? Because when you are changing this division sign to multiplication, you find the word inverse. T1 will come up, 1 will come down. So this multiplied by this, you have T1 over T2. So this whole nonsense here becomes T1 over T2. So we have T1 over T2 is equal to root of M1 over M2. So everything that we've been proving since boils down to this. Now, the most important thing on what you should know while giving a solution to a problem like this is for you to just basically find or memorize the formula, apply it, and then you continue your solving. So, substituting in this formula or substituting in for this formula, we have our final formula says T1 over T2 is equal to root of M1 over root of M2. Please remember this. Now, from indices, we can say T1 over T2 is equal to root. Use one root and cover all of them since both of them are having roots. According to the law of indices, which states that when you have root A over root B, the same thing as root what? A over B. So that's what we did here. Now, in this case, our T1 is for oxygen. So we have 50 divided by T2 is what we are looking for, all over the mass of oxygen is 16. But we have oxygen gas. Now, for oxygen gas, you have it as O2, which is 16 times 2. So the molar mass will be what? 32 over the molar mass of hydrogen is 1. But for hydrogen gas, you have it as what? H2. So which is 1 times 2. The molar mass will be what? 2. Now, this cancel this. What are you going to get? You are going to get 50 over T2 is equal to root 16. So this becomes 50 over T2 is equal to 4 over 1. Now cross multiply. 4 times T2 becomes 4T2 is equal to 50. When you divide both sides by 4, this cancel this, and your T2 will be what? 12.5. So you see that hydrogen gas of the same volume will diffuse what? Faster than what? Than oxygen. That makes sense because the atomic mass of oxygen or the molar mass of oxygen is higher than that of hydrogen. Are we getting it now? And the formula says, the law of diffusion states that the rate of diffusion is inversely proportional to the molecular mass or to the molar mass. That is to say that the higher the molar mass, the lower the what? Rate of diffusion. And the lower the molar mass, the higher the rate of diffusion. So that is how to provide solution to a question like this. Now, you may not want to go and prove everything that has I proved on the board to get my final listing. Now, the best thing to do is just plug in your values into this and then you simplify. So that is that for that question. Now, the next question says, what is the mass in grams of copper deposited at the cathode when a solution of copper 2 tetraoxosulfate 6 is electrolyzed for 10 seconds using a current of 5 ampere? Let's take out our parameters. We have current I, 5 ampere. What other thing again? The mass of copper, that is a constant, 63.5 gram per mole. What is the mass in gram of copper deposited when a solution of copper? Okay, the time is 10 seconds. The time is 10 seconds. Now, the first thing to do, or let me just brief you a little about electrolysis. What is electrolysis? Now, as the name implies, whenever you hear of the word lysis, what comes to your mind? Now, lysis means what? To break down. Lysis means what? To break down. Like when you have lysosome, lysis, hydrolysis, use of water to break down something. Electrolysis, use of what? Electric current to break down something. So electrolysis can be defined as the chemical decomposition of a compound whenever electric current is passed through it. So whenever electric current is passed through something and it decomposes, we call that word electrolysis. Now, in electrolysis, you have two electrodes. You have what? Two electrodes. I believe this topic is not a new topic to us. The two electrodes are the cathode and the anode. Oxidation takes place at the anode and reduction takes place at the cathode. Now, for this question, we are made to understand that the host or something happened at the word cathode. Now, so it's a reduction reaction. So when copper 2 tetrahydrosulfate 6, when it electrolyzes, you have it as copper 2 plus 2E minus to give us Cu. This is in solid, this is in aqueous. Now, why is it like this? Now, for reduction, electron is being gained, and copper is a divalent metal. Now, how or why do we have this plus 2 here? When you have copper sulfate, if copper sulfate should break down, what are we going to get? Now, the sulfate ion is carrying 2 minus. Of course, we know that. Also, copper is carrying 2 plus. That is the reason why when these two come together, they will cancel out. Then you now have what? Copper sulfate. So whenever this copper sulfate is electrolyzed, what you are going to have is what? Copper 2 plus. Now, why do we write the copper 2 plus and not the SO4 2 minus? Now, we are told that the reaction is at the cathode. Reduction occurs at the cathode. That means that the cathode is the negative terminal or the negative electrode. And because it is a negative electrode, it attracts the word positive. That was the reason why we did write SO2 minus, rather we wrote what? C2 plus. This is the reaction that occurs at the cathode. Is that clear? Yeah, that's the reaction that occurs at the cathode. Now, this is a stoichiometric reaction. Now, when the reaction is balanced, you understand that when two electrons or when 2 Faradays of electricity were passed through, 1 mole of copper was deposited. Now, this brings us to the Faraday first law of electrolysis, which states that the quantity or the mass of an element deposited at an electrode is directly proportional to the quantity of electricity passed through it. So the quantity of electricity that is passed through this will determine the mass of the elements that will be what? Deposited. Now, for this case, 2 Faraday of electricity deposited 1 mole of the compound. Now, 1 mole of copper contains how many grams? 1 mole of any compound or of any atom contains the atomic mass. 1 mole of any atom contains the word atomic mass. So 1 mole of copper contains 63.5 gram per mole. And 2 electrons equals what? 2 Faradays of electricity. Now, 1 Faraday of electricity is 96500. So from this stoichiometry, we can say that 2 times, because we have E minus, that means Faraday, which is 96500 column, which is the quantity of electricity, is equal to Cu, is the mass. The mass is 63.5 gram per mole. 63.5 gram per mole. So that is to say that 2 Faraday of electricity gave what? 63.5 gram per mole. This is the theoretical. That means the one that has been experimented and tested. Now, you now carry that your own experiment. Your I was given to you as 5 ampere. M is 63.5. T is 10 seconds. Now, you have to calculate the quantity of electricity that was liberated for this reaction. The quantity of electricity Q is calculated as Q is equals to IT. So our Q will be equal to, now our I is what? 5 ampere times T is 10 seconds. And this gives us 50 coulomb. So 50 coulomb of electricity was supplied for this particular one you did. Now, relating it with the original or the theoretical, you have 2 times 96500 coulomb gave us 63.5 gram per mole. Therefore, 50 coulomb will be equal to S. What do? You cross multiply. Now, if you cross multiply, what are you going to get? You're going to get 2 times 2 times 96500, which is this times this, times our x, which is this, is equal to 63.5 times 50. So we have 63.5 times 50. And at the end of the day, to get S, what do? We divide both sides by what we have up there. So this becomes divided by 2 times 96500 divided by 2 times 96500. Now, when you do that calculation, what are you going to get? If you cancel this and this, S will be equal to 63.5 times 50 divided by everything here will give us 0.016 gram. So 50 coulomb of electricity will liberate 0.016 gram. Of course, you saw that this 2 times 96500 liberated 63.5. So it is expected that 50 coulomb will liberate what? Less. So whenever you are given a question like this, how do we approach it now? Let's take it softly. The first thing is to write the half equation. Now, the half equation, how do you know if it's oxidation or reduction reaction? Now, the question says it occurred at the cathode. Now, because it occurs at the cathode, the reaction, any reaction that occurs at the cathode is a reduction reaction. So, and I told you that copper sulfate, whenever copper sulfate splits, is split into 2 ions. Copper 2 plus ion and SO4 2 minus ion. Now, because this one is a positive ion, it will be attracted to the negative word terminal, and the negative terminal is the word cathode. That was the reason why we took this and not this instead. Is that clear? That was the reason why we took this and not this instead, because the reaction is taking place at the cathode. Cathode is negative. Positive will attract to the negative. So that is what happened. Then it receives 2 Faradays of what? Electricity, and then discharge what? Copper at the cathode. Now, have we done that? From the balance equation, we said one of these E here has values of Faraday, which is 96500, is equal to, then we have copper is 63.5 gram per mole. So if this is equals to D, now for this question, we are giving I to be 580 to be 10 seconds. How do we calculate for Q? The quantity of electricity. Q is equals to IT. I is 5 ampere, so you say 5 times, time is 10 seconds, which is 50 coulomb. When you cross multiply and simplify, you get your final answer. So that is how to prefer solution to that question. Now, the next question is a very simple one. The next one is a very simple question. Now, the question says, calculate the current in ampere when the quantity of electricity used is 300 coulomb in 5 seconds. Calculate the current in ampere when the quantity of electricity used is 300 coulombs in 5 ampere. Now, you are given your values. What were the values given to you? You are given when the quantity of electricity used is 300. So, we are given Q is 300 coulomb. What other thing are you giving again? We are giving the time as 5 minutes. Now, the first thing is to convert this time in 5 minutes to what? To seconds. How many minutes make 1 second? 60 minutes. So, how many seconds make 1 minute rather? 60 seconds make 1 minute. So, you multiply this by what? By 60. So, 50 times 60 will give us 300 seconds. Now, from our understanding of this, we stated that the formula for quantity and current is Q is equals to IT. Now, if you're asked to calculate for the current, is unknown. Our Q is what? 300 or 3000 coulomb is equals to our I is what we are looking for times T is what? 300 seconds. Divide both sides by 300. This cancel this, and your I will be equals to 3000 divided by 300. This cancel this, this cancel this, this cancel this, and everything here gave us what? 10 ampere. So the final answer to this question is 10 ampere, and that is option that. Okay, the next question is a very cheap question also. Says, what is the pH of a solution with H plus concentration 1 times 10 raised to power minus 12 mole per dm cube? What is the pH with H plus concentration? Now, what is the formula for pH? The formula for pH is not Port is minus log of H plus. That is to say that the pH is equal to the negative logarithm of the hydrogen ion concentration. The negative logarithm of the hydrogen ion concentration. Now, our hydrogen ion concentration was given as 1 times 10 raised to power minus 12 mole per dm cube. Now, substituting this into this equation, you have pH is equal to minus log. We have 1 times 10 raised to power minus 12 mole per dm cube. Now, pH will be equal to, when you punch this in your calculator, you don't need to stress yourself. Just punch this in your calculator. What are you going to get? You are going to get 12. Direct. So that is the answer. The answer is 12. Option D is the correct answer. So that is that for that question. Whenever you are asked to calculate for pH, pH is the negative logarithm of the hydrogen ion concentration. The hydrogen ion concentration is given as H plus as this. Substitute in and give. Now, in a situation where you are not giving the hydrogen ion concentration, how do you calculate for it? If you are not giving the hydrogen ion concentration, but you are giving the OH concentration, how do you calculate from it? You can use the formula H plus bracket OH minus is equal to 10 raised to power minus 14 to get your hydrogen ion concentration in case OH minus is given to you. But that is not the case for this question, so you leave it as it is. So that's basically much for this particular one. Now, another question on electrolysis. The question says, calculate the quantity of electricity in coulomb used when the current of 27 ampere is passed through a solution of silver salt for 25 minutes. Calculate the quantity of electricity used when, now our current is 27 ampere, is passed through a solution of silver salt for 25 minutes. Our time is 25 minutes. Now, we know that Q is equal to IT. Q is what? IT. Now, if Q is equals to IT, your T is not in seconds, so you must convert to seconds. That gives us 25 times, converting this to seconds, multiply by 60, and that will give us what? So we punch our calculator, that will give us a particular value. That will give us about, okay, let me just do it here, since I don't have a calculator here. This multiplied by this will give us 0, 300, 0, 12 rather. So this gives us 0, 0, 5, 1, 1,500, 1,500. Okay, this is 2.7. Okay, 1,500. So our time 1,500 seconds. Q is equal to 2.7, which is our current, times 1,500, and our Q is 4050 coulomb. So that is basically it for this question. It's very easy. Whenever they say calculate the quantity of electricity in coulomb, your use Q is equals to IT. Make sure you convert your time to seconds. Make sure you convert your time to seconds. Now, this is a very tactical question.